How is a professional soccer ball made? To answer this question, join me as we visit the Adidas facilities, where the balls for the most important competitions worldwide in this sport are manufactured. It is a multi-stage process that combines human labor and specialized robots. As for the materials, the most common for the outer part are polyvinyl chloride and polyurethane. The structure of the balls varies according to their use. From professional to indoor balls, all share a construction in three main parts: cover, seams, and bladder. The cover of a professional ball initially used to have 32 panels, giving the ball the characteristic shape seen in animated series like Super Champions. Nowadays, balls have increasingly fewer panels, being manufactured in shapes and sizes that improve their aerodynamics when struck. These are made with high-quality natural or synthetic leather, meticulously stitched or glued by hand. Between the cover and the bladder, several layers of polyester or cotton coating are placed to maintain the ball's integrity. Next, we must delve into the importance of the canvases or inner layers in the manufacturing of a ball. The thickness of these materials plays a crucial role in their quality, which is why multiple layers are added between the bladder and the outer cover. These layers, made of polyester and cotton, are laminated but not glued to provide the ball with strength, structure, and bounceability. In professional balls, generally 4 or more inner layers are used, while recreational or practice balls usually have 1 to 3. These layers not only contribute to maintaining the shape and bounce of the ball, but also prolong its lifespan. In many cases, a foam layer is included to offer better cushioning and control during play. This process ensures that each ball has the appropriate durability and performance, regardless of its level of use. Here we move on to the essential component, which is the bladder of the ball, responsible for retaining the air necessary for its use. Typically made of latex or butyl, butyl bladders are notable for their ability to retain air for longer periods compared to latex bladders. Although latex bladders offer better surface tension, butyl combines contact quality and air retention excellently. For example, in futsal balls, the bladder is filled with foam to control the bounce on hard surfaces. Natural latex provides a soft touch and a more delicate response, but its microporous-based construction can cause it to gradually lose air. However, there are options for latex bladders with carbon, which use carbon powder to seal these micropores and maintain softness and bounce. Rubber bladders offer a good balance between touch and air retention, being common in recreational balls. If you've ever owned a ball, you know that valve damage after extensive use is very common, which is why this is an essential element in ball manufacturing. Most balls use butyl valves due to their excellent air retention capacity. However, high-end balls often incorporate silicone-treated valves to enhance their performance. Silicone-treated valves offer greater protection against air loss and allow for smoother handling of the inflation needle. To ensure optimal operation, it is advisable to apply a few drops of silicone oil to the valve when acquiring the ball. This provides the same effect as silicone-treated valves. Once all parts of a ball are prepared, the next step involves cutting and gluing the outer panels of the ball. This process is essential to ensure the structural integrity of the ball and secure its durability during play. In the systems currently being implemented in sports competition balls, sensors are being added inside the air bladder. This chip is added using mounts that suspend it within the bladder when the ball is inflated, ensuring it withstands impacts. This sensor helps referees to position the ball on the field, and once the ball has completely crossed the goal line, it notifies the referee of the goal's validity, thus avoiding human errors. Once all the components are gathered, we enter the die-cutting stage, where the ball panels are cut according to a previously established design. This phase is carried out once the materials are completely dry and ready to be molded. The die-cutting process is performed with specialized machines that ensure precision and uniformity in the cuts. These machines are designed to adapt to the specific design of the ball, ensuring that each panel is cut exactly according to the required specifications. This phase is crucial for shaping the ball and defining its final appearance. Precise die cutting ensures that the panels fit perfectly together, creating a high-quality ball with optimal performance. In the next process, the cut panels move to the screen printing room, where the manufacturer's logo and designs are applied. This process is crucial for customizing and giving identity to the ball, adding the graphic elements that distinguish it. In the screen printing room, the screen printing technique is used to precisely transfer the designs onto the ball panels. This technique ensures a faithful reproduction of logos and designs, ensuring a sharp and professional appearance. Each ball goes through this process to receive its visual identifiers, which can include the manufacturer's name, the team's logo, or any other relevant graphic element. Here, the final details are outlined, especially regarding the ball's internal bladder. Currently, synthetic rubber is commonly used, which is molded at high temperatures until it takes the shape of a balloon. Once cooled, it is slightly inflated to facilitate the sewing or gluing of the cut panels, a process that is still done by hand. Subsequently, all the components are assembled until a perfect ball is achieved. The classic free kick in soccer can reach speeds of up to 110 kilometers per hour. However, to achieve that speed, it is crucial to have a perfectly spherical design that minimizes air resistance. The problem with traditional leather balls is that they tend to deform and lose qualities over time, much like our skin. For this reason, the specialized team at Adidas set out over the years to create a unique design that not only made the ball rounder, but also more resistant to wear. The curves of the new designs represent a significant improvement over the classic pentagonal structure that was used for years, which are intertwined to eliminate straight lines from its surface, making it smoother to the touch. Inside the ball, there are two additional layers previously mentioned, a lining of polyester or cotton and a latex core that ensures it maintains its shape until the final whistle. These three components turn simple synthetic leathers into a perfect spherical shape. An additional challenge for the engineers was to make the ball completely water-resistant, as some balls tend to absorb water, increasing their weight by up to 50%. Waterproofing is crucial, as a wet ball becomes clumsy, losing its bounce and rotation capability. The weak point of old balls lay in the seams that joined the panels of the outer layer, which wore out over time and could become non-waterproof. Our ingenious solution was to do away with these seams and use innovative thermal assembly technology to join the panels. To ensure waterproofing, the new balls are subjected to exhaustive testing in a water absorption analyzer, simulating real game conditions. The results speak for themselves, with current balls having 0% absorption in 90-minute game simulations. After creating a waterproof and aerodynamic ball, the next step is to test its durability under the most demanding conditions of modern sports practice, before being sold to all lovers of this sport. Now, when you kick a soccer ball, you know all the process behind it.